All right, we're here talking about tattoo machines today. This is your typical electric tattoo machine. This style of tattoo machine was originally invented as an electric engraver right around the turn of the century by Thomas Edison. The patent was bought by a famous Long Island tattooer, and over the years it's developed into a variety of different shapes and configurations. Basically, the way it works is an electrical charge basically makes these two little copper coils. It just has an iron core with copper wire wrapped around it. It charges it and makes a little bit of a magnetic current that pulls the armature bar forward. And as it pulls the armature bar forward, it breaks the connection here, so that the armature bar returns to that original position, and basically as that little circuit opens and closes, it makes this armature bar vibrate. And then attached to the armature bar, you have a little needle bar that has a group of needles soldered onto the end of it that rides inside of a tube, and that motion back and forth is what creates the tattoo. Each machine is set up to do a different job. Some machines are set up for lining, some machines are set up for shading. Different machines that are designed to do different jobs have different geometry. Basically, you can see that there's a longer distance between this point and this point on a shader, and a shorter distance between this point and this point on the liner. You can also tell by looking at the springs. The shader has a longer back spring, and sometimes a longer front spring too. Basically, the longer spring makes the armature bar move a little bit slower with a little bit more power. The longer the needles are in the skin, the more pigment it leaves behind. And to get more holes put closer together, you want the lining machine to run a little bit faster. And also, it's not going to hit quite as hard just because you have more needles in a tighter configuration, so you don't want to cut somebody open with it. You just want it to leave a nice smooth abrasion. Yeah, basically the little clip cord here, there's a lot of different kinds of clip cords. This clip cord is wrapped up and it gets changed out in between customers just for hygiene purposes. And even though it's the machines operate off of DC power, the current still flows through the machine in one direction. Usually there's a little arrow on the capacitor to tell you which way the current's supposed to flow. You can see the little capacitor on the bottom side of this one. Anyway, the clip cord usually on most of them hooks into a little attachment that's insulated from the frame. It has two little plastic pieces that make sure that this one is only hooked to the wiring. It doesn't come in contact with the machine. And then this wire basically hooks right into the frame and acts as a ground. So basically the current does a little circle through the wiring, which is inside of here, and then connects to the rear binding post here, which is also insulated from the machine frame. So the current does a little circle through here, and the current is basically interrupted by the armature bar moving forward. The power gets to the machine from this power supply and is operated by a foot pedal, a little foot switch. So basically when you touch your foot to the foot switch, it makes the machine run. This power supply, basically it gives you, this particular one gives you precise information about, basically about what your machine's doing. So this not only provides power, but it gives you a readout telling you how fast this little armature bar is moving. In other words, how many times the needle is cycling through somebody's skin per minute. The little duty cycle number here basically tells you, gives you information about what your little springs back here are doing, and the volts tell you how much power is going into your machine, and the follow-through basically tells you how efficient this little, basically how efficient your little connection is opening and closing. So basically this transforms alternating current from the wall socket into basically like what comes out of a battery. Alternating current versus direct current.